Welcome back. In example 2, we're asked to find the region in the first quadrant that's bounded above by y equals the square root of x and below by the x-axis and the line y equals x minus 2. So we have a lot going on in this, a lot of different boundaries for our region. Now, the curves have been sketched in figure 4, so you can see the square root of x function springing out of the origin. Then we've got this line y equals x minus 2. And we've also got the x-axis, it says, is the bound below. Because these two curves by themselves don't actually close off any regions, right? There's an infinite region that escapes between the curves to the left and also to the right. So we need some other kind of bound in order to completely enclose a region. So that's going to be the x-axis down here. In fact, I'm going to go ahead and just draw that part of the x-axis that's going to bound on below. Try to draw some more straight line. There. So there's our region. Now, one of the things that's going to be helpful is to figure out the starting and the ending x values of our region. One of the things is we're going to need to find those intersection points like we did in example 1. So let's go ahead and start by doing that. Notice from figure 4 it looks like we need to figure out where the square root of x curve intersects the x minus 2 curve. Let's find that intersection point. Intersection points. Use PTS to represent points. Whoops. There. Okay. So we have square root of x equals x minus 2. As we talked about in example 1, we just set the functions equal to each other and solve. Now we've got this square root of x, so what can we do as a first step to get the x out of the square root, or to get rid of the square root? So if you said square both sides, that would work. That's how you can get rid of a square root. Just square it away. Now when we square this binomial, remember that there's a middle term. That's often forgot about, so it's x squared minus 4x plus 4. So not just x squared minus 4 or x squared plus 4 or anything like that. There's a middle term. And then we'll take that x, slide it over to the right, subtract it to the right, and now we can factor. Looks like 1 and 4 will do the trick. So we have x equals 1, x equals 4. Now we can get the y value at each of these points. So we have, let's see, x equals 1. X equals 1, we're going to get y equals 1 right here. And then y equals negative 1 for the other one. Wait a minute. At x equals 1 doesn't seem to be an intersection point at all. So what's going on there? X equals 1 doesn't really satisfy the original equation. It makes the left side the square root of 1, which is 1, and the right side 1 minus 2, which is negative 1. Those aren't equal to each other. Well, what happened is x equals 1 satisfies the after squaring equation. If you plug it in after you square, that works out. On the left side you'll get 1. On the right side, if you plug this in, you'll get 1. But before you squared, you had 1 and negative 1. And those were not equal. So although x equals 1 satisfies the post-squaring equation, it doesn't satisfy the original pre-squaring equation. And so that's not really going to give you a point of intersection. So we're going to have to cross that one out. It doesn't solve the original equation, which we need to solve for there to be an intersection point. Now, x equals 4 solves the original equation. You get 2 on both sides. Y equals 2 on both sides. So there's a little rhyme to remember when you're solving an equation. If you square, you must beware. You must beware of these extraneous solutions, these extra solutions that don't solve the original equation. And that's what we got here. Now in example 1, we didn't have to square, so we didn't have to beware. All right. So here we've got this point of intersection, x equals 4 and y equals 2. I'm going to go ahead and draw 4 here. And just for fun, we'll write 2 over here. The x value will be the most important part of it. But in terms of sketching your graph, it helps to know where the y values are. Now, the other thing, too, is we need to figure out where this line here along the x-axis intersects this line, y equals x minus 2. And if you can either do it algebraically or just kind of think through it. You just have to think, where does the y equals x minus 2 line equal 0? So where is y equals 0 and this y equals x minus 2 line? And for that, you just plug in y equals 0 and you get x equals 2. So you could just kind of observe that this is going to be x equals 2 right here, where these two intersect. But you can also write it out. That works as well. And if you did, it would look something like 0 equals x minus 2, so x equals 2. So that's the other intersection point. Okay, now when we think about taking this interval from x equals 0 to x equals 4 and breaking it up into a bunch of subintervals and then raising up a rectangle on each subinterval, notice that there's something different about these rectangles over here and these rectangles over here. What's different about these two kinds of rectangles? So if you notice, the bottom function is different for the rectangles between x equals 0 and x equals 2, and the rectangles between x equals 2 and x equals 4. And that matters because when we try to go and take our integral of the top function minus the bottom function, it looks like changes depending on where you are on this interval. From 0 to 2, it's this horizontal line, y equals 0. From x equals 2 to x equals 4, it's this line, y equals x minus 2. So one thing we can do to figure this out is to just break up our area into two separate areas and handle them separately. We'll have a separate integral for each of these two areas. So we'll break it up right here at x equals 2. Then we'll focus on finding the area on the left with one integral, and then the area on the right with another integral. And we'll just add the two results together. Okay, one thing to help us will be to draw label all of these curves to remind ourselves what the formulas for these curves are. So like on the top here, we've got y equals square root of x. That's the square root of x curve. On the bottom of the 0 to 2, this is the x-axis, which is y equals 0. And then from 2 to 4, we've got y equals x minus 2. There we go. So let's go ahead and find our areas. Let me try to highlight which area we're looking at first. Let's say we're looking at the area from x equals 0 to x equals 2 first. To set up that area, that integral, you would look at the integral from 0 to 2 of the top function, which would be square root of x, right? That's on the top of this rectangle, it's the square root of x function, minus the bottom function, which is y equals 0. And you don't have to write the minus 0 if you don't want, but I'm just putting it here for extra emphasis. And then we have dx. Okay. Now remember that to integrate the square root of x, we want to rewrite it as x to the half. Then add 1 to the exponent to get x to the 3 halves. Divide by that new exponent. Now dividing by 3 halves is the same thing as multiplying by 2/3. Right? When you divide by a fraction, it's like multiplying by the reciprocal. So dividing by 3 halves is the same as multiplying by 2/3. Then we can take this from 0 to 2, and we end up with something like 2/3 times 2 to the 3/2, which if you work it out, sorry, I had an itch. One of these 2's can come out and multiply to this 2, and you'll have a 2 to the half left over, so the square root of 2 left over. So you'll get 4 radical 2 over 3. There we go. Now let's take a look at the second area. So that's the first area. Let's take a look at the second area. I'll shade it this way. So to set up this integral, we have the integral from 2 to 4 of the top function, which again is the square root of x, minus the bottom function, which is now x minus 2. That's x minus 2 now. Now we want to subtract the whole bottom function, so we want to put this in parentheses. It's minus the entire x minus 2. It's not just minus x and then minus 2. It's minus the whole x minus 2. So we're not just subtracting the first term, we're subtracting the whole results of the function. Then we have dx. Now from here, it's just doing the same kinds of things. So remember, you can turn the square root of x into x to the half, and then you'll get 2/3 x to the 3/2 once again for that term. The x will, when you integrate it, turn into x squared over 2. The 2 will turn into a 2x, just like in example 1. So I think we've done enough of the work here to, you can rewind and go back to those parts if you're wondering how to integrate each of these parts. But from here, and throughout this course, I'll put some ... dots. Beware of the ... dots. That just say you can fill in the details. Again, if you have questions, feel free to ask. You know, you can say, oh, I worked this through. I didn't quite get the same thing as you. Can you look through and check to see where I made a mistake or something like that? You can also check with other students to see if they can spot your mistake as well, which I encourage. But I'm going to put these ... dots here, both in this video and in the future, to say there are a bunch of steps here that you got to work through, but there's nothing too surprising. There's nothing like new to really talk about here. It's kind of like, I don't want to say tedious. It can be fun too. Therapeutic, meditative maybe, but I'll leave that as an exercise to you. A gift from me to you. All right, in the end, we end up getting something like 10/3 minus 4 root 3 over 3. Sorry, 4 root 2 over 3. Can't even copy down the answer right. All right. And so then we have the area of the right-hand region. So now what we do is add these areas together to get the total area of the region. Let's do that here. Total area will equal the 4 root 2 over 3 plus, and then 10/3 minus 4 root 2 over 3. Notice how the square root fractions cancel, and you end up with just 10 over 3. So the area of that region is 10 over 3, or 3 1/3. Okay, I just noticed that a lot of that work that I did in the first one wasn't showing up, so I'm going to poke up a little bit. My head was in the way. Knew I should have moved my head down to the bottom right. Oh well. There will be some mistakes in these videos, and we'll just roll with them. So you can pause the video if you want to write the rest of this down. All right, so that's it for example 2. Thanks for watching, and we'll move on to example 3 in the next video.